Hello everybody, welcome back to another exciting Ask the Trainer. I'm Jonas from the Maxon training team, and today I am joined by a few nice colleagues of mine and friends. And here we have Ellie, Noseman, Darren, and in the background we have Dr. Sassi and Michelle answering questions in the background and adding some more information. So yeah, it's exciting times. We had a release yesterday, and today we are gonna talk about that. But that was just like a really sneaky teaser, because first I'm gonna do the housekeeping. All right, so here we go. I want to keep this short. We have this website here, which is the Maxon events page. And if you go to the Maxon website and to news, events, you can go here and see all of the fantastic webinars that we are doing. So you can join us and get trained, learn a lot of stuff. So today is Ask the Trainer. Then tomorrow we are going to have Hashi, Seth, and Michael in VFX and Chill, and they are gonna talk about Pyro. We have the ZBrush Summit running, not at the moment, but soon. And then next Monday we have one of the MoGraph Monday webinars, and next Thursday Maxon Color. In case you don't have, or you didn't manage to watch any of these, you can always go to the Maxon training team YouTube channel, and then you can rewatch all of the webinars that we are doing, and it is a ton of stuff here, a lot to learn. So go check it out, subscribe, and be a happier person. And then also, we want to give away free t-shirts. So we want to thank you for your attendance. So you will be getting a link in the chat and a passcode. And you need to enter that passcode to get into that shop then. And here you can order one t-shirt for free, and you only have to pay for the shipping. All right, that's it for the housekeeping stuff. So I think that was short. I'm gonna switch over to Noseman now, and he's going to show you some Pyro stuff. And I'm also happy that you already asked some questions here. So yes. Noseman, you've got the screen already.
Thank
and
you. Well,
you
hello
can start.
everyone. Thank you very much for the introduction. Jonas.
Yay!
No problem. Did I mention that Thanasis is the best looking tutorial person out there?
I mean, I don't know about that.
I'm not sure if that came across clearly yesterday, but
the looks look for themselves, or if
all right,
that makes any sense.
But it's not just
that. The looks speak for themselves, right? That's a weird expression. Anyway, so please take my photo off if you can. I don't want to distract people. So what I'm going to do is a mishmash of some freestyle things. I'm going to talk about some first principles so you can understand a bit better what the Pyro system is, how it works, and what it's based on. Now, all this is going to be covered in a few weeks. We're coming out with a couple of series for simulations and Pyro and all that. So I'm going to begin by answering some questions from yesterday and from today. So the first question I'm going to answer is, how do you render Pyro using standard renderer? And that's a very, very simple one. You can't. Full stop, forget it. Pyro cluster has absolutely nothing to do with Pyro and all that kind of stuff. The only relationship is that it has 4 common letters, Pyro, nothing else. So forget about that. So how do we render stuff? With Redshift. Everyone has Redshift, whether it's CPU or GPU, you can render Pyro. Very quickly, this will allow me to show you some of the first principles. Now, I've created a sphere. I'm going to add my typical Pyro. I'm going to click play, and you have fire. And I want to take this and render it, do some, let's say I want to do a look development for this particular flame, which I've been working on for the last 5 milliseconds. So first of all, you switch to Redshift. Any emission can only be calculated using brute force. So don't expect to use irradiance point clouds for the actual illumination component. So I just switch it to brute force because I've got a GPU and I'm fancy. So what I'm going to do here is just render in the Redshift render view. I do I have a Redshift layout? Maybe, but anyway, let's bring up the render view. Let's dock it. There we go. Click play, and absolutely nothing happens. So this is one of the first principles of Cinema 4D's Pyro. I said it yesterday. I'm going to say it again. I'm going to repeat it as many times as I want. What you see in the viewport does not exist inside Cinema 4D's memory. All right? But it doesn't matter if you can understand why. What's important is that it doesn't exist. What you see here is just a visual representation of what's going on inside the GPU currently. And that component of the GPU that's doing this is unrelated to what's happening in the render component of the GPU. So in order for us to render this, we need to, first of all, bring it inside. So let's assume over here, this imaginary box is the GPU, right? I need to bring it from the GPU inside Cinema 4D, then put a shader on it. Then it's going to send all the data back to the GPU and render it. So let's do that. I'm going to create a material, the new Pyro volume. Excellent. Then I need to go to this Pyro object. And the main function of this, other than just holding a mirror of the project settings, these are the project settings, right? These are just mirrored here. These settings here do not belong to this object. It's just a shortcut, so you don't have to go Command D and click on this and then click back on this. So the important part of the Pyro object is this, and it contains all the grids. And when we talk about grids, we're talking about volume objects. So if I make a fog volume, if you take a volume builder and put a cube underneath it, you're creating a fog volume. Let's make a fog volume. Forget about this for a second. What you see here, this fog, which now we have much better viewport representation, is a volume grid named 1, 2, 3. So these grids, these volumes with parameters, go to Cineversity, check out my full volume builder and volume measure series I did a couple of years ago. It has all the information you need to know about volumes. So a grid is just a bunch of 3D pixels called voxels that contain numbers. And they can represent the density, which is the smoke, the color, which is the color, the temperature, fuel, velocity, pressure, divergence. I have not used divergence and pressure yet. I have used all the others in various setups. So what this little panel, which is the most important panel to understand before you begin rendering, is that what are we going to bring inside Cinema 4D? Because again, this is just a preview. It doesn't even exist here. Cinema 4D thinks it's something, but it doesn't really exist. You need to bring it in, and you bring it in by turning it on. I'm going to zoom in. I'm going to turn it on. You can see some little change here, maybe a few artifacts. There you go, something like that. That's just a representation of the grid coming back into RAM. So we have brought the data for the smoke, and we're going to bring the data for the temperature. Now, this little bugger here has allowed Cinema 4D to see the actual data, which means it can pass it on to Redshift. So what I can do is just drag this over here, and I'm going to expand this, render. And you can see now your simulation. So the simplest thing you can do to render Pyro is to click this and turn on whatever channels you're going to use. The channels are defined by the Pyro volume. I'm going to pull this on my other window. And you can see in the scattering, we get the density channel, this one over here. And in the temperature, over here, let's close the absorption, open the emission. In the emission, we get the temperature. And currently, it's what's called a black body. It's some sort of physically based expression of temperature. Excuse me. So you can control how hot this is going to be, more or less hot, putting various parameters there. You can go to the advanced, and you can change these to make it brighter or not. And it's not refreshing for some reason, which I don't understand why. Interesting. Okay. Let me go back. Oh, it's just taking its sweet little time. Okay, so back to the shader. Now, uh, I'm going on to the second question. This is just importing the values from those volume objects and representing them as whatever colors are described, either the temperature or you can use the color ramp, this ramp over here. And you can see the temperature here is represented by this gradient, which on the right side are the high values and the left side are the low values. So I'm going to answer the second question, which is how we can make blue fire, for example. Now, let's assume I just want to go and render the fire, not the smoke. So I can go back to this and put it back to black body. I don't want the smoke. And by the way, if I add any kind of light source, we get a better representation of the smoke because smoke doesn't emit light, and it's better to see it this way. So let's go back to our shader over here. Now, there's one minor limitation currently, where if the density is empty, nothing will render. We will only see the sphere, and if the sphere is invisible, we won't see anything. So let me type density over here, and we're going to get this back. So we do need something in here. Now, here's one of the interesting things. You can use different channels. I can put the temperature in here. So I can go and say, I want the temperature to be rendered as scattering and the temperature to be rendered as emission. So you can play with these because the shader doesn't care what the data is. As long as there's some numbers in there, it's going to interpret them into whatever that is. Nonetheless, if I want to remove the density, whether I put temperature here or anything else, so let's put back density, all you have to do is go to absorption and just set it to 0. And this will remove the component of absorbing any light, which means it's going to make it transparent, so to speak. So now you have a pure flame without any smoke. And now you can go to your color ramp, and you can use this ramp by, let's load something weird. You can see the left is where the low values are of the flame. So I need to make the one, Jonas said that yesterday as well, that it needs to be the black part. But overall, this is now your flame. This is an expression of the temperature using this ramp. But always remember that the temperature is quite high. The initial temperature we had here is a massive value of 4,000, I would say Celsius or something in that effect. Does anyone know if it's Celsius or Kelvin or something like that? Anyway, I think it's Celsius.
Celsius.
It's Celsius. Thank you very much. So that means
Wait, black body or pyro?
The temperature. The
temperature in pyro is Celsius. Black bodies, I think, are like Kelvin degrees.
Okay. Thank you very much. So in order for us to shrink this color down here, first of all, we can go and change the scale. And this will sort of shrink the whole thing and get a different area of this gradient. Because remember, these numbers exceed 1. These are very high temperature numbers. Or you can go and just manually grab this whole thing and sort of just move it here and move it as close to the left as possible. And you can art direct this. And let's do that. It's too hot. And now start bringing this down. And you're going to get a few more colors in this. And it's all about zooming in your gradient and managing to get as much of these, let's say, temperatures aligned as much as possible. I'm trying to select all these now, and I can't. The other thing you can do, you can go to the Advanced tab and play with the emission. I haven't had huge success with this lately for some reason. I don't know why, but the emission remap range should allow you to do some of these things. This is something, it does something, but not what I would expect. Probably I don't know how to use it properly. But nonetheless, playing with this gradient in some sort of way, and let me replace. So the multiply with ramp and the replace will give you a slightly different result as far as I know. Let's put this closer. Further? No, I want to put it closer. There we go. And the white is that the temperature is just too extreme. Let me divide it by 100 and see what happens here. There you go. So now you can see that once we get these values and we make them much, much smaller, we're starting to get interesting effects. So although we started with a flame, now we can make a plasma something. And you can use all the pyro generation tools to fill objects with fire and so forth and make them look like whatever you want. But these are the basic principles. You have to condense your gradient and make your values a bit lower here to allow more of, let's say, normalized values to come in. And you can see that the lower this becomes, the more we get a reasonable gradient. You can't really control the remapping of the gradient. It is what it is currently, unless you remap the volume itself. Now, talking about volumes, and let me accelerate here. The whole concept of Pyro is based on volumes, the VDV volumes we can create ourselves. So essentially, what happens, and let me just open a new document, is that the emitter. So I'm going to make this object, and instead of putting an emitter on it, right, instead of putting a pyro emitter on it, I'm going to put it under a volume builder and set this, as I did before, to fog. And it's creating a square volumetric object. So this could have, if I went and added to this a random field and made sure that it's set to objects below, and I went in my random field and changed the type, let's say to Luca, my favorite noise, and made it bigger and stuff like that. You can see that we are essentially sculpting the volume here. We're creating areas with higher density and lower density, right? What the Pyro simulation does is that it creates, based on the settings of the emitter, a volume internally or on the surface that has various values using the various turbulences. These are these parameters here. And instead of one volume builder, it builds seven volume builders. Seven. One for density, which is just a float, just like the fog. A color, which is a vector, has 3 numbers for each voxel. A temperature, which again is a single number for voxel. Fuel, velocity, again, this is a vector because it shows direction. Pressure and divergence. It internally creates these 7 volume builders. And once it's creating them, it throws the data on the GPU using some magic fluid dynamic algorithms and just calculates for each consecutive frame how this grows, how the values move, how the density changes when it goes upwards because of buoyancy and all that. But the essence of the Pyro simulation, which is represented by the Pyro object, is that you just get for each frame 7 volume builders that have different types of data. When put together, they create something that resembles fire or smoke and stuff like that. So the fundamental thing you need to know if you're going to start doing fancy stuff with Pyro is to watch the volume tutorial and try to get more familiar with the concept of volumes, because it will allow you to understand what's going on when you see something like a fire and so forth. So let me see what other couple of questions I can have here. So blue fire would be the previous one. You can just change those colors and do whatever you want. Now, another question I had from my very good friend EJ yesterday, which I think, no, the question originally was asked by Thanos, Motion Punk. And it was, what's the difference between the object voxel size in the tag and the voxel size of the simulation? And for that, I've created a Photoshop file, which is a blank image. Now, imagine this is your surface where you're emitting fire. The Pyro voxel here, this one here, defines how big your paintbrush is going to be. So every time I touch this, you see it's quite big. So here I have a higher, let's say, voxel size, because my voxel, so to speak, right, this is just an analogy, is quite big. It's this blocky thing, whereas a smaller voxel size. Oh, my PC is I'm pressing the size. I don't know if it was if my audio was transmitted. Anyhow, this is a smaller voxel size, so we make these smaller things. So when we are creating Pyro on an object, it just wants to know how big your brush, so to speak, is going to be to paint this. But all the other effects are going to be based, and I'm going to take this and get a small little brush. All the effects, which is the execution of the simulation, is going to be always calculated. And let me smudge, let me blur it all. Everything is going to be based on the resolution of the actual simulation. So although my smudges are big because they're low resolution, the actual effects, you can see, look at all these details I'm getting here, are much smaller. So essentially, it's just like having a bitmap image where you can do the same brush size for both, but it's finally the image resolution that's going to define the final look of it. The general rule overall, I mean, just to keep some sanity, is to just have them, unless you're trying to achieve something very particular, it's better to just align this and align this. But essentially, this is going to be the final resolution and what's going to be visible. This will be visible on frame 1 when the simulation is generated. And that's pretty much it. So, let me see. Make blue fire, explain some principles. Yeah, and the last thing I'm going to do for Demis, my friend Demis, has to do with some dissolving text. And I put this together. I'm not going to go into too much detail, just going to let you know a few things on how to do that. I'm creating some text, and I'm using a linear field to dissolve them, and a few more other parameters. So you can do stuff like that. And the basic concept for this is I'm using the text, and in order to just create a bunch of smoke that doesn't accumulate, I've animated the enable of the density to last only 1 frame. So let me quickly show you how you'd go about doing that. So let's go and add a pyro tag. I'm going to try and do this in just a couple of minutes. And I'm going to turn off my geometry. I don't want to see it. And this is going to burn, right? I don't want it to burn, so I'm going to turn off temperature. So we only get smoke. You can see that we get this smoke and it's moving. Number 1, I want this smoke to be more smooth when it's generated. So in the tag, go to noise strength and set it to 0. So it's going to be generated more smoothly. Excellent. Now, the other thing I want is the smoke now is accumulating. So I only want, let's say, 10 amount of smoke. This doesn't really mean anything. It's just 10. I want 10 and I don't want any more. And I'm going to animate the enable. So I'm going to go to frame 1. This is enabled, and then frame 2, and I'm going to disable it and add a keyframe, and you will see that it's going to create this puff, and everything is moving around because in our simulation settings, whether you go from the Pyro or the simulation settings, there's a turbulence thing. I'm going to turn the turbulence off. And in this particular case, I don't care about buoyancy. I'm going to set it to 0. You can turn off gravity if you want to do that. And you can see that this is a bit more stable here, but it's fading out. And that's because there's some default in the dissipation. And dissipation means how fast your smoke or fire or whatnot, or your temperature dissipates. And I do not want this to dissipate. So 0 dissipation for all these, just put it to 0, although most of them are not relevant because don't have temperature. And now we have a stable bunch of smoke. There you go. So that's how you create a stable bunch of smoke. For the letters I did yesterday, I made 4 objects and I used the color parameter here because you can change the color of your smoke. And I just used different colors for each. I think I'm going to make it blue. And finally, to finalize this, we need 2 more components here. I'm going to use a few forces, and but let's take a turbulence to begin with, because now we don't have any forces that are built in the simulation. We're adding forces through our own force objects. And always remember with the new simulation core, it's good to have these quite high if you want to have a good result. I'm going to increase the scale here to make it a bit more whimsical. There you go. So you can see now it's sort of breaking apart like that. At the same time, I can go and add maybe a wind to blow things in a certain direction because I want these to blow in a certain direction. So now we're going to see this blowing once I increase this, let's say 150. So now it's doing two things. It's changing the turbulence and it's changing the wind. Maybe I have too much smoke accumulating here. Go to a frame where you can see this and set this to 1 maybe, so you can play around with how dense the smoke is, and you can see now it's sort of dissolving as well. Small values for these kind of things, bigger values for large-scale explosions. And now I'm going to control this just using fields in the way we already know. Now there's one little issue I saw this morning, which is if I use the same field in more than one force, it becomes yellow. It doesn't work. So what I realized is that I'm going to do a wind linear field. So the wind has the W. I'm going to make a turbulence, a T, and put it in the turbulence. And I'm just going to make these two children. Now, this actually can work to your advantage because maybe you want the turbulence to come in before the wind. So it's good to have separate. And now you can see it doesn't really move. And when I move this, it does that. So you can control how this is going to be. You can put a rotational force to do stuff. And finally, because it's not dissipating, you do not want this simulation to go into perpetuity because it's going to fill up your GPU RAM. And you just want these to disappear. And here I'm going to add the final thing that, sorry, Darren taught me. And that's I'm going to use an object that generates sort of a slightly bigger object that generates pyro density. And what this is going to do, I'm going to turn off the temperature here. I'm going to set it not to surface but to volume emission, and I just want to be able to see it. So I'm just going to go to render, put a display here, and put lines. And what I'm going to do is put minus, let's say, 1000 density. So essentially it becomes a density absorber. I think these are called vacuum cleaners in some sort of way, or filtration devices. So the minute it starts touching that, it's going to sort of absorb the smoke. And all I have to do, and you can sculpt it. This is the amazing thing. You can sculpt how your smoke is going to be absorbed. And then this starts doing other cool stuff, or something that Chris Schmidt showed yesterday in his video. You can even change the color so it becomes yellow when it touches that, because it transfers the
That
data.
was so cool.
That was so cool, yeah. I mean, Chris does some amazing stuff, and yeah, I didn't teach him everything he knows. I can only say that about EJ, no one else. But nonetheless, by using a combination of these things, now you have a very controllable simulation, and you can even sculpt things. You can make this bigger. You can use other shapes. You can move this to remove some of the smoke. You can bring it here again, and then the smoke is going to come back because it's sort of sucking the smoke, and so on and so forth. And yeah, I think that we're at the point now where there are too many things you can do. Anyhow, I'm going to be reading the chats. Now I'm going to pass it on to my next colleague. Ask any questions, and I'm going to be typing in the background or interjecting. It's my new hobby, interjections.
Unless someone else has something queued up, I want to take just a minute or two, and I want to point out something that I don't think any of us have really gotten to.
All right, point out something that nobody of us has gotten to.
Or I'll bring it up and then you'll say, oh yeah, we totally did that, blah, blah, blah. But I do think it is valuable, especially if you find that you're hitting a limit with your RAM. So one thing that can happen, and I'm not going to recreate this right now because who knows if I'll have to restart Cinema, but if you are, so here's the deal. Hopefully by now you know that there is this grid or this tree structure that is created in this system. And we have control over how readily a grid is activated. So a yellow box is activated and it's being calculated, and the purple ones are not activated. And with the Pyro objects thresholds, we can control, or we at least have some influence over how easily these are activated. So I'll put these all down to like their lowest values, rewind, play 170 frames of this. And then I'm going to frame up this grid from bottom to top in my safe frame space. Okay, so now I'm going to crank up the density. So this is emitting, let's see, setting 1 point, we'll say 2, and then adding 10, temperature, 45,000. Okay, so velocity, set to movement, no fuel. So we'll go to the Pyro and whatever, random numbers, 500 temperature, we'll say 5,000. There's no fuel, so that's not going to activate anything. And then my grid spacing is 500. Let's just make that 5,000. And I'm going to rewind and play. And we're going to see this is greatly truncated, right? So it's still actually, calculating in there. They're yellow, but not out here. So this is a greatly exaggerated example, but I just want to show you that you do have control over how these are activated, and that you can add additional cubes or pads to be added to a neighboring existing one with the padding. Now, also keep in mind, each one of these is being subdivided 16 or 32, not subdivided. It's getting 16 or 32 voxels within it. I'm not a numbers guy, so I'm not even going to start thinking about the math between that and the Pyro voxel size, and then the object or surface thickness in the object voxel size within the scene, where one pad is being broken up 16th. Anyway, not going there. The point is, thresholds controls how these are activated. You can add padding. You can also get really low thresholds. We'll go with like a low padding here. And let's go one more. But in some scenes, you will notice that you can actually get away with a very low padding because maybe your dissipation is such that it actually sort of fades off quite quickly. So you actually don't need a whole bunch of activated grids around what you actually need, which is just right here in the middle. Anyway, that's it. Thank you. L'chaim.
Alrighty, then I'm gonna take over here, and I was a little bit confused here with the kill box, and this is something you might also run into. So I'm showing what Noseman just showed. So this is actually what should happen when you use negative values in a second Pyro emitter and use it as a kill box. However, this didn't happen immediately, and this was because velocity was enabled here. And once I enable that, you can see that we are getting this little colliding thing, or colliding behavior, which is actually not what we want when we create a kill box. So let me disable this again. And also in that kill box, it might be a good idea to bring down the noise strength here to 0, and then it will work. So here we go. Here's our kill box. All right. Yesterday we had another question about XPresso or using Pyro with XPresso, and yeah, I already showed one example where I linked like the global alignment of an object to the to the velocity direction of Pyro, I want to show you another thing. And what I have here is a pretty simple setup with a sphere and a vibrate tag on it. And it's doing this, right? But let's say we don't want any Pyro, or we want Pyro, but we don't want temperature. And let's say we want to colorize this, but based on the position of the sphere here. So we can also do that using XPresso. So let's go to programming tags and let's add an XPresso tag. And now we need two things. We need the sphere and we need the Pyro tag. And what we can do is from the sphere, we can use the global position output. And in the Pyro, we can use, I'm gonna find it here. Tag properties, density, color, this one here. And global position is a vector with X, Y, and Z in it. And color is also a vector with R, G, and B in it. So what we can do now is we can do, let's see what happens if I just connect the two like this. Yeah, you can see that we got black smoke for now, unless it's going into the positive directions, I guess. Well, it doesn't really work like that. So you need a range mapper. So the range mapper is down here. I don't know if you can see it. Maybe let me right click here and let's go to XPresso, calculate range mapper. And we're gonna throw this in here. So now it's in the middle and we're going to range map these values. And in this case, we need the data type to be vector. And then we just say, okay, the center of everything is supposed to be 50% gray. So we need negative values on the input lower and positive values on the input upper. So let me do this. I'm going to go with 100 or minus 100 for the lower one and plus 100 for the input upper, so that the middle is 0, like the center of these values is 0, the average. And the output upper is 1, because 0 is black and 1 for everything is white. All right, and now let's see if that worked. Oh, for some reason it didn't work. Let me see. What did I do wrong? That is interesting. I thought I did the same thing earlier. Let me go here. This is the color. All right. That is interesting. So let me do this with the...
I gotta say, I'm loving to see you getting into XPresso. Yesterday when you did it, that was awesome. And today, this is awesome. Thank you.
That's great to hear, Darren. But I would actually prefer if it would also work. And
it's user error. XPresso works.
RGB. Yeah, I'm pretty sure that I did something wrong here. I just don't know what. I think I used the global position and this color. Let me see again. Not gonna use the spline maybe.
It's a cool thing about XPresso. It's like it's been around forever. It's still capable. It could use some love, but one of the things that always gets me is, when do I use like a matrix over a position? There's like, with like the old.
So yeah, the matrix has more values in it than just position. The matrix is a mix of position, scale, and rotation, whereas the position is just the position. But if you have a look at the adapters here, and you have this matrix to vectors adapter, you feed in a matrix, and then you get those 4 vectors out of it. And offset is position. That's pure position. And V1, V2, and V3 are actually these axes that you see here, and their alignment or the axis vector, so to speak. And the vector has a direction or an alignment, let's say a direction, and also a length. So
Dude, that just blew my mind.
By that, so with V1, V2, and V3, you can control the rotation as well as the scale. However, that doesn't solve my problem for now.
Sorry.
But just that you know that, well, that actually, well, I don't know. Let me see. Here we go. So I'm using the global position. Let me read this to see if we are really adjusting something here. Let me go to general and result, and let's just have a look. So yeah, something is happening in here. Maybe if somebody of you has something else to show, then I can troubleshoot that in the background and then show.
Is that is the Pyro color a variadic input? Or is it because if it's not a variadic input, it won't be able to provide a new color per component?
Well, I don't know, but it should work because it worked earlier. So maybe
pictures or pictures.
Variadic sounds.
Never happened.
Variadic is fancy.
Yeah, that's how they call it. Yeah.
So do you want to show something else in the meantime while I'm troubleshooting this?
I have something to show if you want.
I really love Noseman's fireball.
Okay. I'm going to switch over to Noseman's screen.
But he has something anyway.
I'm going to show some examples I did this morning. These are what I call 5-minute doodles. That's Darren's screen, I think.
Yeah, you have to grab the screen.
Oh, I have to do that. All right, I thought I can blame someone else. The dog ate my homework. Let's see. I'm looking at the feedback. There we go. So here are a couple of examples, as you can see, very simple, 4 objects. And this is some sort of meteor shower. And the concept behind this is extremely simple. You use a standard emitter. You use a cloner in object mode, and you use the emitter inside here. And you apply your tag on your cloner. And then you just play around with resolution, make it a bit more high resolution. And here you just add fuel instead of temperature. And you can just create things falling from the sky. And you can use your gravity forces if you want to change these, or any of the forces here, because they work with particles. And if you don't want them to affect the simulation, you just go to your simulation right at the bottom and exclude them from the forces. And that way you will avoid any feedback loops or any unnecessary interference. I did, because someone's going to ask about, what about thinking particles? Well, here's a very simple example of thinking particles. And I think someone asked at the same time, I think Pixelasm asked how, instead of going here, typing the name, I have this expool open, and I just go here, MatterWaves, and drag them in. I find that very convenient. So I'm using a MatterWaves to emit particles from an editable, not edible, but editable emitter. And I'm creating 2 groups of particles for anyone that uses thinking particles. One is the initial, one is the explode. So the initial ones are in the group initial and are green. And then I'm just passing the data to gravity objects so that the particles are going to have some sort of gravity to them. I can turn these off, this one and this one, so that you can see how the particle simulation. So the particles, they just go up with a slight arc because of the gravity, and then it just gets the data, and when the particle dies, it creates a p-storm that emits one particle at the position of death, which is blue, and puts it in a group called explode. If you're interested in more thinking particles tutorials, please let us know on Twitter and other means. Maybe if there's enough interest, we can do some more. Anyway, and then all you have to do is create 2 cloners. One where you drag from the thinking particle settings the initial, one where you drag the explode. And what this will do is it will create little clones, spheres in this particular case, with the pyro tag. So it's going to fire up, and the minute the particle dies, you're going to have an explosion. And using thinking particles, you can make secondary and tertiary explosions and so forth. And I did put this together in less than 4 minutes. So I'm pretty sure that if you dedicate a few hours, you can do something quite interesting. Now, the things I didn't try, can you transfer the color to the pyro and all that? Since Jonas insists that it works, now I'm curious. So I'm going to look into that. Oh, good. So I'm very looking forward to seeing this. And before you start, just another extremely simple thing. I have a model tire here. That's it. On the tire object, I've put a vertex map with a linear field and a decay. What the decay is going to do is, as the tire rotates, it's going to carry that slightly with it, and then it's going to dissolve, right? So it creates a decay. And then I'm going to use this vertex map to drive the both the density, and I think I'm adding, I don't have temperature, I have density and no fuel. Yeah, just density, because I'm doing a burnout, and burnouts have a smoke. So it's going to emit the smoke from that vertex map. And then I added, so this is the wheel, and then I added a rotation force, and I added, that's pretty much it. Some lighting and RS volume, and there you have it. You have a wheel that's producing smoke while it's rotating, and when it stops, I've just animated the density emission to become smaller. But you can use procedural manners to control that. Again,
you could totally trace that and use the spline as a temperature emitter. So you have fire on the floor and then the smoke on the tires.
Yes, you can. Yes, you can. Or you can use it in front. All right, let me do that, because that's what happens in the training team. Someone says something, a new idea, someone else does something based on that idea, then someone else says, oh, why don't you try this? Anyway, I'm going to create a second one. Hopefully this is going to be temp, and I'm going to go to my fields and remove the decay. And let's see if this is going to work. I'm going to go to the temperature, enable it, and put the second one in the temperature. Let's see if that's going to do anything. If it doesn't, I'm just going to drop it. There you go. Boom! On fire.
Yeah, now I love it.
Now I know everything. I'm going to save this. Okay, thank you very much, Darren, for the idea.
The next step is the Back to the Future. The Back to the Future, fire trails. Anyway.
Yeah, portals, fire trails, and all that. They're all doable now, and you can play with the volume shader. You can take the screen, Jonas.
Yeah, I'm not there yet. I'm not there yet for some reason.
You're not there yet.
I'm just trying it in a new scene right now.
Okay, so let's see if we have any questions. It's so cool. It's amazing. Wheel fire showing the way to create, to use. What else can I show? All right, let me show you something. Another fancy thing you can create from a blank screen, and you can abuse our very good friend, Mr. Rex. So this is a C-motion scene. Let's see how well this is going to work. What I'm going to do to this guy is let's find the actual, let's go here to the subdivision surface, and I'm going to add a pyro tag, and you press play and you have a dinosaur on fire. Isn't that cool? So let's go and put it on his tail. So I'm going to go to other vertex map, select the vertex map, add a linear field. I can never find the linear field. Never. There you go. I don't know what it is about the linear field where I can't find. So plus Z, I think. I'm going to move it back here. I'm going to turn off deformed points so it keeps this over in the same points while it's deforming. And I'm going to go here and say, okay, let me emit from here and emit from here. And now the tail should be on fire. There we go. Isn't that amazing? But if I add a bit of fuel, because I have really nefarious intentions he's extinct, all right? So who cares? We can go to the fuel and put on some fuel on him. Well, a bit of fuel on him. Let's put 0.1. And now he's laced with fuel, and I think Darren showed it yesterday. If you want to see the different the different grids generated, go to your main settings and down in the drawer. Yeah, was it Darren? Yeah, it was Darren, I think. You can change which one of these you can visualize. So fuel, if I go forwards, you will see that now we can see the fuel. So this gives you a visualization of the shaded view, which is all the density, all the temperature, fuel, velocity, no velocity at frame 0, and pressure. So now what will happen is that his tail is going to light on fire, and then the rest of the dinosaur is going to combust. Why isn't he combusting?
So how much fuel is he emitting? Is it default? It's continuous 0.1. There you go.
Yeah, there you go. I had too little fuel, right? So if you're planning,
could you bring up the combustion parameters since you're talking about fuel, just so we can put everyone's eyes on the combustion parameters so they know where to go to adjust?
So go to the settings and not the forces. There's some down here. Is it the thresholds?
Up.
Where are we?
There you go.
You can show Darren. Grab it and
combustion is right there. Fuel burning rate, ignition temperature, density per fuel. Yeah.
And all that. And these will provide you with an overall number of how things are happening, how fast the fuel is burning, what is the ignition temperature which you can use for fuel to ignite. And here's something you will not find in any tutorial yet. If you lace something with fuel and you want it to combust immediately, of course you can go and add a temperature of 10 to make it combust. But if you go to your settings and you set your combustion temperature to -1, then fuel combusts spontaneously.
What?
Yep. One of the devs told me that if you put it at -1,
that's cool.
You can combust. So you can fill your scene with all these little thingamadoodles and just have it combust at any temperature. So you don't have to have the fuel burning rate. I said Buell burning.
Bueller?
Fuel burning.
Yeah, and overall, you can play around with these and try and read what it does. Jonas, are you done?
Yes, finally.
Excellent.
So I'm
Raise
going to
the
switch
Pilz.
to my screen. So to be honest, I don't know what I did wrong. I just recreated the scene, and now it works. Maybe it was some parameter that I didn't set up correctly. Most probably it was. However, what I did here, again, is this little XPresso setup with the sphere, and it's reading the global position, and then the range mapper. The input I set to -500 on the lower side and +500 on the upper side, and then the output. So because this is position in centimeters, and here the output is 0 for all of them, which is black, and 1, which is white for the upper output. And yeah, that's basically it. And then I can press play, and you can already see that there are different colors in here. And let's do its thing. Let it do its thing for another second. So what it's going to do now is whenever it goes into X direction, it will bring up red. Whenever it goes into Y direction, it's going to bring up green. And whenever it goes into Z direction, it's going to use blue. And I also already set it up so that it renders. And this is what it looks like. So you can see that right now we're going into the pink area. Up here we are totally in green. Here on one corner it's going to be black. On the opposite side it's going to be white because we just created like some sort of, let's say, cube that's going diagonally from -XYZ to +XYZ, and +XYZ would be white, and minus XYZ would be black. But if you just go in one direction, you will get the color. Whenever you just go the straight line between the minus values and the plus values, you will always just have values of gray. Yeah, that's basically it. So are there any more questions?
Why are you on a green screen?
Why?
That's one question.
The thing is that I just got it yesterday and I'm excited about it. That's the best answer that I can give.
That's perfect.
Also,
okay, I have a few answers for a couple of questions.
Yes.
Andrew Batson.
do you want the screen
I don't
back?
know. These are, I don't really care. Put us all on, and anyone that needs a screen can get it. So, Andrew Batson, what is the RS volume object? It's the equivalent of the volume loader in Cinema 4D. So, it just loads VDB files, and it gives you a list of the grids. It can load animations and stuff like that. So, it's the equivalent to the volume loader.
Exactly. Let me elaborate on that, because one
Yes,
thing that might confuse people is that here we have the Pyro object, and actually these two tabs here are the ones that this Pyro object actually has. The Pyro tab here is actually grabbed from the preferences. So if you go to the preferences by doing Command D or Control D on a PC, you can go to simulation, and here we have the Pyro tab as well with the very same settings. So these are the same as these in here. So whenever you change something here, it will be changed in the project settings as well. So keep in mind that these are like the Pyro scene settings, so to speak. Yeah, and
if you change one, the other one's going to change.
Exactly. So this is more or less like the volume exporter for Pyro, the Pyro object, and this is more like the Pyro emitter. Maybe we should rename these. So, yeah, that's what I wanted to add. I broke your flow, Noseman. Sorry.
No. You haven't broken. Someone, Bhavana, B Havana, is it B Havana or is it Bhavana with a silent H? Anyway, so there is a good question, and I'm sharing. It says I'm sharing here, but I'm not seeing the feedback from my screen. So let me stop sharing and share again. Thank you, teams. Let's see.
So you want to share?
Yes, please.
I'm gonna give you the screen.
Oh,
there we go.
Merci beaucoup. Merci beaucoup. So a lot of people have seen the examples that our very good friend and master trainer from China, Yang Ye, did with boxes and smokes and all that. And just to let you know, we have those files. So and what you will see in those files, I'm going to use them to make tutorials. So I'm going to go through every single one of them, and I'm going to explain exactly what happens. But just to let you know how certain things, how simple they are. You can start with a simple cube, and you can take a cylinder, put the cylinder on top, remove the caps, and make a Boolean object and subtract one from the other. And I think it's without. It's not without. Subtract B. Anyway, I need to put the caps back on. So let me put the caps back on. And now I have to put A without B. There we go. No, it's A intersect B. No, it's A union B. It's A union B. Oh my God, what's wrong with
A modulo B.
Yeah, sorry about that. There we go. That's all I wanted to do, or put the caps on and just make a single object out of this. I'm going to make it editable and remove these, and we should be able to see down there. There you go. Excellent. So you can make any object you want, pretty much, and you can use this as a collider, because everything you have in the simulation here works together. So I'm going to make this into a collider, but you need to make sure to define the correct colliding side, and the back is in this case, because we're going to keep things inside this little bugger. So display, again, use lines, excellent. And inside here, you can put whatever you want. I'm going to put a sphere. I'm going to set this sphere to have some pyro smoke, no temperature. I'm going to emit from a volume so I can have a bunch of smoke. And I'm going to do this, and it will expand in there, start coming out from the top. And I can guide this by adding various forces and stuff like that. So you can go, the best force I like to use is the field force, because I can sculpt the direction using splines if I wish to do so. So you can go here and you can say, okay, I'm going to get the spline tool, and I'm going to go here and create this line that goes like this and then goes like this for no apparent reason. I'm going to drag it in here, and now this field force will add as object. I put it in the wrong field list. I did it to see if everyone's paying attention. Put it in the object list. There we go. Set this to, let's say, 500. Add to velocity, and now it's going to create these vectors based on the spline. And in theory, it should start sucking up some of our smoke upwards. So I need to reverse the direction. So go here and invert direction. Normalize will make them bigger. So I may need to get but it's good enough. I'm going to turn it off because I don't want to see it. So you can sculpt things just by using objects. So you can make a chimney. You can make anything you want. And what is great about this, I'm going to show you a little trick. Now, we're not creating any fuel here. So if I go to the default draw and say draw the fuel, you see there's no fuel here. And that's because we haven't set any fuel. So let's go and put some fuel here. I'm going to enable some fuel, just set a value of 1. Now you will see the fuel is going upwards. But because the temperature is not high enough, it won't ignite, okay? So one of the things, the genius things that my friend Jan did was he took a little teeny weeny little sphere, undo and move it up. I was drawing a spline by mistake because I had the wrong tool. Don't use the wrong tool. That's, I think, one of the takebacks from Maxon training. Don't use the wrong tool. I'm going to take this sphere and add a very teeny weeny little fire. No density. I'm going to just put a temperature of 10, which is the ignition temperature of fuel, the default. And what's going to happen is this. It's going to light up the fuel. Now, because the fuel is moving upwards, because of the temperature, it's only going upwards. But if I minimize, it is super cool because now we have an industrial burning dystopian future thingamadoodle. What you can do is you can counteract the fuel moving up so fast and it's not sort of burning downwards by changing the buoyancy and doing all sorts of other things you wish to do. So I can go to the extra forces buoyancy, and I'm going to make this -1 just for fun. -1.
What if it's just the temperature buoyancy that you change so that the density is still rising, but the temperature is going down and the burn rate is such that it overtakes the buoyancy? Is that too much?
No,
Okay.
actually. So let's go to the buoyancies, the temperature buoyancy. I'm going to set it to something much smaller. See what that happens now. And let's see if
negative. Like make that like
Negative
a -10 or something.
And look at that. -0.1. Fire, -0.2. And you can, that's the other great thing. You just go interactively and you find the values you want.
Yeah.
Like, honestly, there's nothing easier than doing all these cool. I'm impressed even by just sitting here and trying new things. But this is just an indication of the things you can put together, and the speed and the ease of use is, I think, second to none. And yeah, and don't forget that this is version 1, right? This is just, it has been just been released. So this is one of the things that he did with his firebox, where the flame goes inwards, and you can change the amount of fuel to make. Let's go to our box. Where's this one here? You can reduce the amount of fuel on this so that it won't burn that much. So you will see that it's going to burn a bit slower. It's burning, but the buoyancy is too strong now. So you have to be wary of the counteracting forces and all that. Or you can do the opposite. You can say, let's go nuts with this. I'm going to set a lot of fuel here. And then you can create a nice little explosion. So this will be a very simple and easy animation. You do this, and then you take a volnate fracture, put a little house underneath it, and when you go here, you just activate dynamics. It goes boom. You apply, as I showed yesterday on your fragments, another pyro object to create smoke trails and so forth. So yeah,
That's really, really cool. I know what I'm gonna do tonight again. So yeah, I want to reply to one of the questions that we had in here. I'm gonna grab the screen back.
Please do.
Oops, I just pushed the wrong button, and that muted me. Okay, so what I'm gonna do here, so I want to react to the question, can you transfer the colors into a volume mesh? And the answer is yes, you can. So what you can do is, let me use the Pyro here, and let me just throw it into a volume mesher. And in here, we are going to, in the volume mesher, we are going to bring down the voxel threshold so we get this geometry here. And we can also make Pyro invisible so we can really see this geometry that it's creating. It's really cool. And yeah, now let's say we want to colorize this. And the way you can do that is by right-clicking and go to Other Tags, Vertex Color. And Vertex Color can be driven by fields, of course. And I'm just going to drag and drop this in, and it will automatically grab the color from it. And now everything that we need to do is we create a new material here. By the way, this can now also be rendered in standard and physical with the vertex map shader that can also use vertex colors. So, but in Redshift, the way is to bring up the node graph here, and then I'm going to double click to create a vertex attribute node. And the vertex attribute node needs the vertex color tag, so I'm just going to drag and drop that in and connect this to the color. And now, once we applied this material, you can see in the viewport that it works, and also when we render it, you can see that the color is there. So the answer is yes, that's possible. All right, I feel like we already showed a lot of stuff, and I also feel like we can go for another hour. So my suggestion is that in the next Ask the Trainer, we are just gonna do Pyro again. Please write yes if you agree with me. Use the chat.
While everyone's typing yes or whatever you would like to see next time, I do want to point out, please be careful with colliders with Pyro. High density meshes will really, that's a lot of calculation for Pyro. May not be so bad for other things, but it does slow down cloth quite a bit. So go with the proxy collider if you can. And there was one other thing, and I forgot what it was. Thank you.
But I think it was important.
It was important. Remesh. You can use a zero
Absolutely.
mesh. Yeah, and it's great because you can make a proxy or an instance of something, and you can remesh it, and then you can offset it slightly, so you can keep most of your setups procedural. To find
mesh is just awesome. It's just such a wonderful tool that we have thanks to Pixelogic and ZBrush. The other thing I wanted to say, and I haven't tried this, or last time I tried it when we were, before. Anyway, viewport renderer, right? So we should, I want to say you can you can render Pyro with the viewport renderer, but you know, it's not as cool. Anyway, that's it. That's all I want to say.
All right, so yeah, let me wrap up here by just bringing up my screen again, and take care of another round of housekeeping. So yeah, in the chat, I just saw that many people want another session on Pyro. So the next Ask the Trainer in 2 weeks is going to be about Pyro again. And that's good.
Quick interjection. GRAZDXF, what about rendering of Redshift? Rewind and watch the beginning.
Yeah, we showed that. We showed that. Yeah. And we're, again, going to show it like in 2 weeks, I think. All right. So, yeah, if you want to learn more about the events that we are doing, just go to the Maxon website and specifically to the events page. And you can find that under News, Events. And here you can see all the webinars that we are doing. Tomorrow in VFX Chill, Hashi, Seth, and Michael are going to blow up some things. So definitely this is also very like Pyro heavy. So make sure to check it out. Also make sure to check out the ZBrush Summit and next week's MoGraph Monday Demystifying Post-Production webinar, and also Maxon Color next Thursday, and all of the other webinars that we have here. And just in case...
There are 2 things I want to say before you end, FYI.
Yeah, okay. Now?
Whatever, I just wanted to say something before you said bye and turned us off.
Okay, so yeah, let me finish this website stuff. So if you came in late and want to watch the beginning of this session, or re-watch all of the other sessions that we did, and it's hours and hours of webinars that we did, then you go to the Maxon Training Team YouTube channel and subscribe, and also watch all of the things that we have on here. It's really worth it. There's a lot of stuff on there. All right, and then the last one that I want to show here before I go back to, well, actually to Darren's things that he has to say, is we want to give away free t-shirts. So if you want a free t-shirt, you go to the Maxon store. The link will be shared in a second in the chat, and also the passcode that you need to enter this Maxon Ask the Trainer exclusive wear shop. And then you will be able to order 1 t-shirt for free, and you only have to pay for the shipping. Isn't that great? All right. So let me jump back to our faces here, and let's see what Darren has to say.
Yeah, I just wanted to say 2 things again today that I said yesterday, and I think everyone should hear it. One, if you're a member of a team, you are entitled to complimentary training sessions with any of us on the Maxon training team across all of our products. Just send us a message on training@maxon.net to book a session. And the other thing I wanted to say is for students. Students qualify for all of Maxon's, for all of our products in one all-encompassing bundle for a really, really, really small fee. Yeah, shoot us an email so you can get more information on that. That's all I want to say. Thanks.
These were 2 very important bits of information. Thanks for sharing, Darren, and everyone else out there, spread the word. There is a lot of things that we can do here. All right, everyone. I think we got it, and let's see each other in 2 weeks and burn some more stuff. Bye, everyone.
Bye, everybody.
Bye.
Goodbye.